Landing a plane seems straightforward until you realize that just 3 millimeters of water on a runway, barely enough to cover your shoe, can mean the difference between a safe landing and potential disaster.
That's such a striking way to think about it. And I imagine most passengers have no idea how many variables pilots have to consider before touching down.
Well, you know what's fascinating is that landing performance isn't just about the runway length. It's this incredibly complex matrix of conditions. Like take temperature, for example. The same exact snow-covered runway can be rated completely differently if it's minus 15 degrees Celsius versus minus 14 degrees Celsius.
Hmm. So, how do pilots actually make sense of all these variables in real time?
That's where this brilliant tool called RCAM comes in. The Runway Condition Assessment Matrix. It basically takes all these complex factors and boils them down to 6 levels. From 6, which means dry runway, all good, to 1 which means, we might need to divert.
You know what really surprises me about this? The fact that even a tiny section of slippery conditions can change everything about how they land.
Oh, exactly. And here's something that'll blow your mind. When you have multiple layers of contamination on a runway, like a bit of water on top of ice, most combinations aren't even in the manual because they're just too dangerous to attempt landing on.
So, what happens when conditions start changing during the approach?
Well, that's where it gets really interesting. Smart pilots actually run 2 sets of calculations, one for current conditions and another for what if things get worse? Like if it's raining, they'll calculate for both good conditions and medium to poor just to know their options.
That level of preparation is remarkable. And I understand there's this whole system of pilots sharing their landing experiences.
Right. It's called AIREP. And here's the thing. Pilots are actually required to report if their landing experience was worse than what was reported. But, and this is crucial, they have to be really careful about how they evaluate it, because at high speeds, the reverse thrust can mask poor wheel braking.
That makes me wonder about these specially prepared winter runways you mentioned. How does that work exactly?
So this is pretty cool. Some airports can actually get special authorization to handle winter conditions differently, but only if they can prove it's safe through statistical analysis. Like, they need actual aircraft performance data to back it up.
And I imagine different types of aircraft might handle these conditions differently.
Exactly right. A small regional jet might have a totally different experience than a wide-body aircraft on the same runway, and pilots have to factor this in when they get reports from other aircraft. They need to consider things like approach speed and wheel track of the reporting aircraft.
That's exactly why this whole system of standardized procedures is so important, isn't it?
You know it. And what's really interesting is how the system keeps evolving. Like some airports now have this fancy friction measuring equipment, but here's the twist. Pilots are actually told to ignore those measurements because they don't reliably correlate with actual aircraft performance.
Well, that certainly challenges what most people would assume about runway safety measurements.
And that's really the key point here. Landing performance is way more complex than most people realize. Sometimes the safest decision is to divert to another airport, even if it means inconveniencing passengers, because those safety margins just aren't where they need to be.
This conversation has completely changed how I'll think about landings from now on.
Well, next time you're looking out that window during landing, remember, there's an incredible amount of science and split-second decision-making happening up front, and that's what keeps us all safe, flight after flight.